Greetings everyone. So for my microLED, I'll be actually focusing on the course E225, which is based on and which is actually titled as Analog Electronics 2. This particular course is actually the build-up of the course. It is the build-up of the second year course E212. So whatever knowledge has been gained with respect to the electronic devices such as diodes, transistors, and elementary circuits in E212. This particular unit furthers that knowledge. So, like the course description says, this particular unit builds on the fundamentals of analog design for integrated and high frequency circuits. Having attained basic knowledge of electronic devices like diodes, transistors, and elementary circuits in EE212, this course emphasizes on the circuit intuition and a system design approach. Topics to be covered include operational amplifiers, data converter circuits, power amplifiers, multi-stage amplifiers, frequency response, feedback circuits, signal generator and oscillator circuits, and waveform shaping circuits. A number of circuit design methods and techniques are discussed to develop a reasonable level of circuit design proficiency. It establishes a foundation for further advanced design in system on chips technology. So basically, this particular circuit focus on circuit design and how certain electronic components can be put together to form the amplifier or the data converter circuits or power amplifiers or multi-stage amplifiers for various uses, right? So um, so that was regarding the background of this particular course. So it is another fundamental course actually that is required for progressing towards the third and the fourth year courses. Um, so some of the topics actually covered in this particular unit, like I earlier mentioned, is operational amplifiers, data converters, and differential circuit analysis, multi-stage amplifiers, feedback amplifiers, signal generator and oscillators, output stages and power amplifiers, and yeah. So those are the topics that are actually covered in this particular unit. However, for for my macro LED assignment, I'll be actually focusing on the operational amplifiers over here. That is based on the op-amps. So I'll explain more about on the topic that I'll be actually focusing on. Just before that, let me just go over the learning outcomes. So there's 3 learning outcomes for this particular unit. Those 3 are to explain the analog amplifier circuit operations. Second is to perform experimental work to determine electronic circuit behavior and specifications, while the third one is analyzing design analog amplifier circuits. So initially, this particular program usually this particular course is actually offered as a face-to-face program. However, due to the recent pandemic outbreak, the course has been actually converted to online mode. So all the course deliverables are actually offered through the online platform. So the respective activities allocated for this particular, for the first learning, course learning outcome is lectures and tutorials. So these both lectures and tutorials are actually conducted via online classes through Zoom links, of course. So like everyone is familiar with this so far, I think. The assessments for this particular topic is mostly through examination and tests, so it is mostly formative. Well, there's one uh, one summative assessment, that is the examination, that is final examination, while there's 2 short tests that is actually there to gauge this first outcome, that is that actually acts as a formative assessment, right? So the second second learning outcome is actually assessed through the labs and the reports that is actually submitted. So students have to actually simulate the lab activities and via the LTSpice software. So LTSpice software has been actually prescribed for this unit's lab activities. Right? So basically, it basically does replicate most of the scenarios that is actually given in the lab. So we mostly focus on the LTSpice software. The other activity that is actually focusing on this particular, the other activity that actually focuses on the same learning outcome is the weekly tutorial problems as well. So it is, it somewhat coordinates the lab activities. Um, some of the assessment that is actually focused on this learning outcome are that like I said, the weekly lab reports are there. So weekly lab reports acts as a formative assessment, while there is a weekly tutorial submissions on design problems that are actually assessed for 10 weeks. So students actually need to submit the weekly tutorials every week for 10 weeks, I think. Yeah. So just before the tutorial sessions, students have to actually attempt these tutorial questions that are given for the tutorial, and based on that, they are actually evaluated and marks are given out. For the third learning outcome, that is to analyze and design this, analyze and design the amplifier circuit. For this particular, learning outcome, there's two activities designed for this. Those are lectures and tutorials, and the assessment technique for this is again the examination, right? Plus short test, right? So I actually missed out on short test, right? So examination is one of the summative assessment, while the other assessment is the formative assessment, that is the short test. So like I said, that I'll be focusing on operational amplifiers for my micro LED. So I'll be just basically touching on some of the configurations of the inverting and non-inverting amplifiers. Right? This particular topic actually aligns with the course learning outcome 1. So that is to explain analog amplifier circuit operations, and it also aligns with the course learning outcome 3, that is to analyze and design analog amplifier circuits. So the assessments that are actually linked to these are the short test, that is the formative assessment, while the summative assessment is the final examination. However, for the class, for the respective class, just to gauge, I'll be actually going over the examples and actually giving out some activities for the students to actually go through and attempt, and based on that, I'll be having a fair idea on how well they have actually learned that particular concept, and whether I'll need to emphasize more on this during the tutorial classes or not. So yeah, so that's regarding the alignment of this particular topic that I'll be focusing, that is operational amplifiers. So that basically aligns with the learning outcome 1, CLO 1 and CLO 3. So the activities related to is mostly lectures and tutorials, right? And the two assessment techniques are mostly examinations and short tests. So the same short test has to be. Wait, just let me read this. Yeah, so I'll just write that. So excuse me about my writing over here. Basically, it's regarding the test, right? So two assessments are examinations and tests. There's an S, the N as well, right? So tests. Please excuse me about my writing over here. So yeah, so op-amps are basically op-amps are basically represented by this small symbol over here that is given out. The basic operation of this particular op-amp to amplify the voltage in the voltage and the current signals that are given. Based on the configuration, it will either amplify the current or it will either amplify the voltage. So whatever voltage is given, for example, if it's a voltage amplifier, you can use this as a voltage amplifier. So let's say if you input 5 volt is input, you can amplify that to a larger value, let's say 10 volt, 20 volt, 30 volt, right? So you can basically increase the magnitude. So basically, that is the function of this op-amps. It is basically to amplify whatever input is given to it. So based on the configuration, it will act as either a current amplifier or a voltage amplifier. So the activities I'm actually planning out is to just to give out the basic bands. I mean basic properties of this particular op-amp and some configurations. The inverting and the non-inverting amplifier configurations, right? Some of the configurations, plus I'll be actually giving out a few, I mean, at least 1 or 2 examples to actually go along with this particular problem. Since it's a short class, I'll be actually giving out one example. Plus, I'm actually thinking about giving out one exercise problem, perhaps, for actually to see whether students have been able to grasp this knowledge or not. So yeah, so that's regarding the micro LED. So looking forward to your comments and hope to improve on this. So thank you.